Hey everyone, what we're going to be talking about in this video is flow. And what I've drawn here for you guys is a conversion grid that makes it real easy when you're converting all the different types of flow. So what you have on this top row, you have cubic foot. This middle row you have gallons, and the bottom row you have pounds. So the way this works is the smaller box, anytime you're going from a smaller box to a larger box, then you multiply. Anytime you're going from a larger box to a smaller box, then you divide. And all of these are for 60, all these are 1440, all of these lines are 7.48, and all of these are 8.34. So say you want to go from gallons per second to pounds per minute. All you'll do is take your number in gallons per second, multiply by 60, because this is a bigger box, and then multiply by 8.34, because this is a bigger box. And that's all you'll have to do to convert it. And you can do that with any combination of factors that you want to. Cubic foot per second, all the way to pounds per day. You multiply by 60, multiply by 1440, multiply by 7.48, and then multiply by 8.34. And the same backwards with dividing. So this is a really cool tool for helping you with your conversions and making sure that you have the right factor that the question's asking for. So let's get right into some flow calculations. So let's say that we have a channel, and it is, we'll say it's 1.5 foot by 40 inches by 100 foot. And let's say that the water is moving at, we'll say, 2.3 feet per second. So 2.3 feet per second. So all we'll do is first we have to make sure that we are in the same factors. So inches, feet, we want to make sure that everything is in feet. So this is in inches, so you're just going to take the 40 divided by 12 inches in a foot. And that gives you 3.3 foot. So we're actually 1.5 foot by 3.3 foot by 100 foot by 30 feet per second. So really, we're just going to use this feet per second because we're dealing with flow. We're not looking for the volume. If we were looking for the volume of this 100-foot channel, we'd be using the 100 foot. But since we're looking for the flow, we're going to use this 2.3 feet per second. So to find the cubic foot per second flow, you will just take the 3.3 times 1.5 times 2.3 foot per second, and that is going to give you, this calculator will work, 3.3 times 1.5 times 2.3. So that gives you 11.4 cubic foot per second. So that'll help you help you find out your, say, gallons per minute. So if you take this and then look at our little chart, we're at cubic foot per second. So if we want to get to gallons per minute, say you have a chemical pump or something that's pumping, you don't know how fast it's pumping. All you would do is multiply that number by 60 and then multiply it by 7.48. So when you multiply that number times 60, you get 683 cubic foot per minute. So that same 11.4 cubic foot per second, if you let it go for a full minute, you'll pump the 683 cubic foot per minute. So to find gallons per minute, which is a number that we are more often use in the plant, you would multiply that, because we're going from a smaller box to a bigger box, by 7.48, which equals 5,100, let's say 10 gallons per minute. It's that easy, that simple. So let's do it. Let's say that we have a tank that we're filling up. We'll go with a rectangular tank. in the tank is, we'll go 12 foot by 12 foot by 15 foot. 15-foot height. So we notice that this water level is going up by, it's increasing by 1.25 foot per minute. So we want to know how many gallons per minute we are actually pumping into this tank. So what you'll do, again, we don't need this because we're looking for the flow, so we will need the flow. So we take the 12 foot by 12 foot by 1.25 foot per minute. Multiply that out. That equals 180 cubic foot per minute. So remember, again, your test, if you're taking a test, it'll likely have this answer available for you. Don't just select that answer and move on, because the question asks for gallons per minute flowing into the tank. So we go up here, cubic foot per minute. To get to gallons per minute, all you have to do is multiply it by 7.48. That equals 1,346 gallons per minute. And if you don't have access and you can't remember how to draw it, or you don't have access to it, all these formulas are still located in your conversion sheet on the back page. So you can still find the 60 minutes, 1440 minutes in a day, 7.48 cubic foot in a gallon, and so on. You can find that in there. This just makes it very visual. If you're a visual learner like I am, this makes it super easy. All right, so let's do another one. Let's do one where we are dropping. We've got a tank. Say we have a tank 8 foot wide and 10 foot long. So we've got 8 foot by 10 foot. We'll say 15 foot again, even though we already know, since we're doing flow, it doesn't matter. But they will have extra numbers in these questions just to try to throw you off. So don't let that get you. So the water, we'll say the water drops. The water level dropped 2.8 foot in 2 minutes. Make it just a little bit tricky. We want to find how many, the gallons per minute flow coming out of this tank, because it's dropping, so the flow is coming out. We're pumping out of it. So since we're wanting to find the gallons per 1 minute, the first thing you want to do is convert this to 1 minute. So that will equal, you just divide it by 2. That is 1.4 foot per minute. So this is the number we're actually going to use. Again, I like to get all those conversions out of the way right in the beginning so I don't get confused when I come to the end of the problem. So we're looking for gallons per minute, so we have it in 1 minute. Now we just have to calculate the cubic foot per minute flow rate. So you take the 10 foot times the 8 foot times the 1.4 foot per minute. And let's see what that gives us. We got 10 times 8 times 1.4. We've got 112 cubic foot per minute. All right, remember we're looking for gallons, so you take that cubic foot per minute, multiply it by 7.48, and that'll give you your gallons per minute. And we'll round up. That equals 838 gallons per minute. All right, so let's do the same thing with a cylinder. So we have a cylinder, and we are putting water in. We're filling up this cylinder. It's a 30-foot cylinder. We're putting water in at the water is rising at 10 inches in 5 minutes. So just 10 inches per 5 minutes. So we want to know what the flow rate is going into this tank. So again, the first thing that I always do, you got 5 minutes, we're looking for gallons per minute. So you divide that. Oh, excuse me. I wrote down 10 inches. Oh, okay, 10 inches. Sorry, I'm confusing myself. So we got to go in, we're in inches and we're in foot. So we got to put this inches into foot, and we have to put it into 1 minute. So the first thing we'll do is we'll put 10 inches into foot. So you got 12 inches per foot divided by 10. That's not right. Okay, 10 inches divided by 12 gives you the 0.83 foot. That's another important thing to notice. If you mess up, we know that 10 inches is not 1.2 foot. So we know that we inputted something wrong in the calculator. That can happen. You just kind of use logic and catch yourself when you make those mistakes. We got 10 inches going into 12, so that gives you 0.83 foot per 5 minutes. So then you just divide that. Anytime you say per, you can divide it. So 0.83 divided by 5. We'll round up to 0.17 foot per minute. Alright, so we're dealing with a cylinder, so we got to take that 0.785 that we used from the first video times the 30 foot, because we're doing 30 foot squared, times 30 foot, times 0.17 foot per minute. Then we just multiply all that out. So 0.785 times 30 times 30 times 0.17, and that gives you 120 cubic foot per minute. So we're looking for gallons per minute. Again, we take the cubic foot per minute, multiply by 7.48, and we get our gallons per minute. 898 gallons per minute. Alright, let's do another one. So we've got a cylindrical tank that is 2 foot in diameter, and we are pulling out of it we're pulling out of it by 2 foot in 30 seconds. So we're emptying this tank in half a minute. This is quite the undersized tank here. So first thing we want to do is take this to minutes. 2 foot divided by 30 seconds. We're already in foot. 2 foot and 2 foot. So 30 seconds is 4 foot per minute, because you will multiply that by 2, because there's 30 seconds twice in a minute, if that makes sense. 60 seconds in a minute divided by 30 is 2, so you multiply that by 2, which equals 4 foot per minute. So if you go 30 seconds, in 30 seconds, if you can fill this thing up by 2 foot, if that goes for a full minute, it will have gone up 4 foot. That's another way to kind of understand that. So we'll take 0.785, because it's a cylinder, times 2 foot times 2 foot times 4 feet, so we're at feet now, per minute. You get 0.785 times 2 times 2 times 4, and we'll round up to 12.6 cubic foot, we'll say cubic foot per minute, CFM. Alright, so to get that to gallons per minute, again we're at cubic foot per minute, multiply by 7.48 equals, again I think I typed something wrong because that's supposed to be a much larger number than that. 12.6 times 7.48, there we go, 94 gallons per minute. That's how fast we are pumping into that cylindrical tank. Alright, so let's turn our cylinder to the side and let's do a flow through a pipe. So we've got our cylinder. There we go. It's a 6-inch diameter pipe, and our flow going through is going to be 3 feet per second. Alright, so we want to get these both into feet per second. It's not 3 inches per second, it's 3 feet per second. So 3 inches into 6 equals 0.5 foot. 6 inches is half a foot. So this diameter is half a foot. Alright, so you just plug it into our equation. 0.785 times 0.5 times 0.5 times 3. And when you multiply that out, you get 0.785 times 0.5 times 0.5 times 3. Again, these calculators, I keep hitting something wrong. 0.785 times 0.5 times 0.5 times 3. There we go. We got 59 cubic foot per second. Alright, so let's say that the question is asking for gallons per day. How much is our flow in gallons per day? So you take your cubic foot per second, and then you will multiply by 60. So times that by 60, times 1440, and then times 7.48. So that is 380,493 gallons per day of water going through this pipe. Alright, let's kind of reverse the problem a little bit. So instead of finding the flow rate, let's say we start with the flow rate. You know the flow rate. We want to know how full the pipe is going to get at this flow rate. So say we have a chemical pump and the flow meter requires the pipeline to be at a full pipe. We need to find out, we know how much the chemical is flowing. We just want to see how full that pipe is going to be. So let's say we have a pipeline. That is, we know that the flow, we're moving at 3.6 feet per second. We know the flow rate is 0.7 cubic foot per second. And we want to know the diameter. So this is going to be our X. We want to know how full this pipe is going to be at 0.7 cubic foot per second and 3.6 feet per second. So we take 0.7 cubic foot per second, and that equals 0.785, because it's a circle, times x squared, because we don't know what the x is, that's what we're trying to figure out, times 3.6 feet per second. So it's the same formula we've been using, but instead of the x being over here because we are looking for this flow, the x is here because we're looking for the diameter. So the way you get something across the equal sign here is you have to divide. So you take 0.7, divide it by 0.785 times 3.6. We want to get that x alone. That equals x squared. So when you do that, we'll multiply the bottom first. 0.785 times 3.6 equals 2.826. Divide that by 0.7. So 0.7 divided by 2.826. And that equals, we'll round up to 25 foot squared equals x2. So we want to get rid of the squared because we just want to know what x is. So all you have to do is multiply that by 2. So you got 0.25 times 2, and that is 0.5 foot equals x. So that pipe will be full 0.25 foot, so half a foot is how full that pipe will be at a flow of 3.6 FPS. Alright, let's see. Just making sure that we've covered everything. We can do another one of these kind of reverse ones with the rectangle. Or for a channel. Alright, so let's say channel is a rectangular cross section. The channel is 4 foot wide. Go with 4 foot. Water flowing at a depth of 1.8 foot. So we know the water level is 1.8 foot. The flow through the channel is 9,050 gallons per minute. What's the velocity in feet per second in FPS? Alright, so we've got to take our we've got to convert our gallons per minute to cubic foot per second. So if we look at our gallons per minute to cubic foot per second, we have to take 9,050 divided by 7.48, because we're going from a bigger box to a smaller box. We're going to seconds, so then we have to divide that by 60, and we get 20.2. We'll round up. 20.2 cubic foot per second. So now both of these are in seconds. So then we take that 20.2 cubic foot per second, and that's 4 foot by 1.8 foot by x. So again, to get the x by itself, we have to divide across the equal sign. So you have 20.2 divided by 4 times 1.8. So let's see what that is. 4 times 1.8. That equals 3.2. You got 20.2 divided by 3.2. Let's try that one more time. 4 times 1.8. 7.2. Got to keep an eye out when those numbers don't quite make sense. 20.2 divided by 7.2, and that equals 2.8 feet per second. That's your velocity. All right. I think we've pretty much covered flow. Hope that was clear for everybody. And I'll show you this one more time if you want to write it down, memorize it, keep track of it. But it helps me out a lot. It is super helpful little chart there. All right. I appreciate you guys for watching.